So the three subatomic particles of an atom are protons, neutrons and electrons. Let's recall their masses. The mass of proton is taken to be 1 atomic mass unit. With respect to the mass of proton, the mass of neutron is also 1 atomic mass unit, and the mass of electron is 1 by 1840 atomic mass unit. So out of these three subatomic particles, which subatomic particle do you think identifies the atom? Is it proton, neutron or electron? Well, let's try to answer this. So here we have a hydrogen atom. A hydrogen atom has 1 proton in the nucleus and it has 1 electron. Now I add 1 more electron. So when I add 1 more electron to it, we see that it still remains hydrogen. The element remains the same, but since an electron is increased, so the total number of negative charges are more, that is, it becomes a charged species, so it becomes an ion. Since the number of negative charges is more, so it becomes a negatively charged ion. So when I increase an electron, it becomes a negatively charged ion, but it still remains hydrogen. That is, the element does not change, it only becomes a charged species. So by changing the number of electrons, the element does not change. It only becomes a charged species, a positive or a negative ion. The chemical properties of an element, they change with the number of electrons. We know that the electrons participate in the chemical reaction. So if the number of electrons change, the chemical properties of an element also change. So the chemical properties of all elements, they depend upon the electrons that are present in the element. So again, we have a hydrogen atom. The nucleus has 1 proton and it has 1 electron. Now let me add 1 neutron to it. When I add 1 neutron to the nucleus, you see that it still remains a neutral atom. That is, we know that neutrons are neutral, they have no charge. So by increasing 1 neutron, the neutrality of the atom is not changed. It still remains neutral. The atom also remains the same. That is, it was a hydrogen atom. So now by changing the number of neutrons, if I add 1 more neutron to it, we see that it still remains hydrogen. That is, the element is not changing and it remains neutral. It becomes an isotope. So by changing the number of neutrons, the element does not change. It remains the same element. It gives rise to isotopes. What these isotopes are, we'll study. And by changing the number of neutrons, the physical properties of the element, like mass, etc., they also change. So as we change the number of neutrons, the physical properties of the element, they change. So we have a hydrogen atom. The nucleus of the hydrogen atom has 1 proton and it has 1 electron in its shell. What happens if we increase the number of protons now? So now I add 1 proton to it. So you see that it's no longer hydrogen, it becomes helium. So by changing 1 proton, hydrogen changes to helium. What happens if I add 1 more proton now? It becomes lithium. So by changing the number of protons, the element no longer remains the same. It changes into another element. So by changing the number of protons, the element changes. And we know that the atomic number of an element is the number of protons. So by changing the number of protons, the element changes. So the atomic number of each atom, it's unique. By changing the atomic number or by changing the number of protons, the element changes. So let's revise what we just studied. By changing the number of electrons, ion formation takes place. So these ions are charged species. So when we increase or decrease the number of electrons, it becomes either negatively charged or positively charged, and so it gives rise to ions. And the chemical properties also change, because we know that the chemical properties of an element, they depend on the number of electrons. The electrons participate in the chemical reactions. So as the number of electrons change, the chemical properties also change. But the element remains the same. For the same element, when we change the number of electrons, it gives rise to ions. By changing the number of neutrons, we get isotopes, that is, isotope formation takes place, and the physical properties of the element change. Physical properties like mass, etc., they change when we change the number of electrons. When we were changing the number of protons, the element changes. It's no longer the same element. That is why the physical properties, they depend only on the neutrons. We know that the mass of neutrons is the same as the mass of protons, and this mass defines the physical properties for most elements. So when we talk of the physical properties, we say that they change with the number of neutrons, because when we change the number of protons, the element itself changes. So it's no longer the same element. So when we talk of a particular element, we say that the physical properties of those elements change only when the number of neutrons for that particular element change. So by changing the number of protons, the element itself changes. It's no longer the same element. So now, which subatomic particle do you think identifies the atom? Yes, it's protons. As we change the number of protons, the element changes. This number of protons is also known as the atomic number. So atomic number for each element is unique. So as we just saw, when we change the number of neutrons, it gives rise to isotopes. What these isotopes are? Isotopes are atoms of the same element, having the same atomic number but different mass number. Atomic number is the number of protons, and mass number is the number of protons plus neutrons. So the number of protons for these remains the same. The only change is in the change in the number of neutrons. So the isotopes are atoms of the same element. That is, the element does not change. Only the number of neutrons in that atom, they change. These are the three isotopes of hydrogen. So we know for an isotope formation to take place, the number of neutrons, they change. The first isotope, that is hydrogen itself, it has no neutron. The second isotope, deuterium, it has one neutron. And the third isotope, tritium, it has two neutrons. So for all isotopes, here Z denotes the atomic number and A denotes the mass number. So as the number of protons, they remain the same for an isotope. So the atomic number for all the isotopes, it remains the same. The change is in the change in the number of neutrons. So as the number of neutrons change, the mass number, which is the total number of protons and neutrons in an atom, they change. So the first isotope has mass number 1, the second has mass number 2, and the third has mass number 3. So isotopes are the atoms of the same element. These are the atoms of hydrogen element. They are the atoms of the same element having the same atomic number but different mass number. This is because of the change in the number of neutrons. So the two isotopes of chlorine are 35Cl17 and 37Cl17. The two of them differ in the number of. We know isotopes are the atoms of the same element having the same atomic number. Same atomic number. We know atomic number is denoted by Z, but they have different mass numbers. Mass number is denoted by A. So this atomic number is equal to the number of protons. Let's denote the number of protons by Np, and the mass number is denoted by the total number of protons and the total number of neutrons. So let's use this representation. Np denotes the total number of protons, N small n denotes the total number of neutrons. So as the number of protons remain the same, because they have the same atomic number, the only change is in the change in the number of neutrons. So the two isotopes of chlorine, that is 35Cl17 and 37Cl17, they differ in the number of neutrons. Now, we know that this denotes the mass number and this denotes the atomic number. Similarly, this denotes the mass number and this denotes the atomic number. So, for the first isotope, that is 35Cl17, let's calculate the number of neutrons. So, for 35Cl17, we get, so we have the mass number here is 35. The mass number is 35. It is equal to the protons plus neutrons. So for this element, we get the number of neutrons plus 17. This comes from mass number is equal to number of protons plus number of neutrons. So we get 35 is equal to the number of neutrons, and we know that the number of protons is 17. So for the first one, we get that it has 18 neutrons. So this isotope has 18 neutrons. Let's do this for the second isotope, that is 37Cl17. So let's take it here. So for this one, repeating the same process, we will get 20 neutrons. So this isotope has 18 neutrons. The second isotope has 20 neutrons. Both of them have the same number of protons. So that is why they have the same number of electrons. The only change is in the change in the number of neutrons. The second isotope has 2 neutrons more than the first isotope. So the two isotopes differ in the number of neutrons. Let's look at some of the properties of these isotopes. The chemical properties of these isotopes are the same. We know that the chemical properties depend on the number of electrons. The electrons participate in the chemical reaction. Since the isotopes have the same number of electrons, that is why they have the same chemical properties. The second property is that the isotopes have the same electronic configuration. The electronic configuration or the electronic arrangement of the isotopes depend on the number of electrons. Again, the isotopes have the same number of electrons. That is why their electronic arrangement remains the same. Further, the isotopes have different physical properties. We know that the physical properties depend on the number of neutrons. Since the isotopes have different number of neutrons, that is why they have different physical properties. So this is it about the isotopes of different elements.